Welcome to the Loctio Country Framework, or else LCF User Interface explanatory video. We start with the login page, where we suppose that the user has already a registered account. Thus, after filling in the username and the password, we press Submit to enter the main account menu. In the home page, all the registered devices on the specific account are visible. The process of registering a new device is not covered by this video, and someone could seek the related instructions into the respective guide. By the way, some useful guides can be directly downloaded from this page as shown here. Moreover, a contact form is available for committing some sort of issues the user might encounter. As you can see, there are some separate fields for asking bespoke guidance, reporting a bug, or proposing a new feature, commenting on anything, or even uploading a screenshot that will help us better understand your inquiry. Let's return to the Prime page now by pressing the Home button. Here, by expanding the panel for each device, the last main configuration is visible, comprising the fields of sublink frequency, the constellations used, the number of the taken position fixes or snapshots, the periods in between two consecutive position fixes, and the length of the snapshots. As you can see, each device shows its last configuration. At the end of the list, always the special purpose virtual device resides, but its functionality and usefulness go beyond the scope of this video. Finally, at the bottom, the number of the registered device is shown out of available 1000 in total for the time being. At the description box, user can define and alter as many times as needed the name of the device. Let's change only the last number now, but the entire name could be rewritten as desired. You can see at the right bottom of the screen this green box that confirms the successful name modification. We do not need any more of those expanded information panels. Before taking a quick glimpse over the history area, I'm highlighting the ID field, which is unique per device, and it is associated with each registration process that precedes. We are moving now to the history panel, where all the positioning scenarios referring to the corresponding trajectories can be assessed. You can see the date and time of the scenario execution and whether it has been completed or not. We will return to this page later. The time has come for initiating a new track, for instructing, in other words, this device to start getting and providing us with its position. And this is the configuration menu. On the top, some non-editable information is available with respect to the last time it was configured. Moreover, device name and unique ID alongside some other account info can be found. We start the configuration by selecting the time scale of the device monitoring. It can be seconds, minutes, hours, or even days. We stick with minutes for this demo, and then we have to select the time interval between the consecutive position fixes in the time. As seen, by increasing the entire duration of the monitoring and keeping constant the interval, the total number of location updates adjust accordingly. At the advanced configuration boxes, we can tune the sublink frequency, which we will keep intact for this demo, as this is the only supported by the underlying hardware of the device. Then we move to snapshot length selection. Here values over 20 milliseconds are not allowed, and the length can go as low as 1 millisecond. The technical warning below just denotes that for the selected snapshot length, 20 milliseconds in our case, at least 9.6 kilobytes of memory should be available at the device for accommodating it. Now it is the turn of choosing the desired constellations to be ticked. At least one should be used, and for this experiment initially we opt for GPS only, as we are going to run on-device processing and this device processes only GPS locally. Later we will have the opportunity to add another constellation as well. In this field, we can name the scenario for easily tracing and retrieving it. I'm just putting number 2 to distinguish it from the previous one. this panel, the reference location coordinates are set. Just to remind you that the reference location should be in a radius of approximately 60 to 70 kilometers around the area where the device tracking takes place. We are ready now to submit the configuration of the device, and this is what we are doing. Let's wait a little bit for the device, carried by our colleague, to receive and apply the configuration and track the request. This green pop-up verifies that the configuration has been successfully applied and the tracking has been ignited. Now we are going to automatically be transferred to the tracking page, which is this one. The tracking page comprises a map that is lively updated every time a new position fix arrives from the device. While we are waiting for the first position fix to come, in this point, just to remind you that since the interval is 1 minute, we should be waiting for 1 minute plus the time needed at the cloud side to calculate the coordinates based on the received data. This extra time won't be way long as much of the processing took place on the device, since we have selected on-device processing. As you can see, there is a Google map integrated here that can be switched to either conventional map or satellite view. For the time being, it presents only the reference point with this blue head marker. We have used our office building for the reference point while one of our colleagues is wandering around the block. Cloud has just received the first packet from the device and it is calculating the position, and this denoted by the index locating down here. And this is our first position fix. For each position fix, a new line is created in this box in time order. Vertical coordinates alongside the calculated height are presented as well as the calculated GNSS date and time in the local time zone. This can turn to UTC time by activating this switch. While waiting for the next position fix to come, let's explore what data we have available and can download for this position fix. We downloaded and zipped this file with unique per position fix descriptive name. I need to unzip one once more. Probably this can be done in a single step, but this is not my bread and butter, especially in Windows. 4 files here. I'm opening the one named AGNSS that contains the AGNSS data. In other words, the visible satellites and the Doppler frequencies at the reference point area for the time the snapshot was grabbed. This data has been used for deriving the position fix. There are some other configuration and data files. For example, snapshot.bin embeds the observation data when on-device processing has been selected. For cloud processing, it holds the entire snapshot respectively. I'm returning to the tracking page now, where we have received in the meantime one more position fix. Our colleague carrying the devices keep moving outside despite the fact that the temperature is too high and walking around is quite uncomfortable. I think that those two position fixes were enough. No reason to prolong this video expecting the rest 8. Thus I'm stopping this tracking test by pressing this red button saying that I don't want anymore the rest of the ordered position fixes. Again, the green box that appears at the down right side confirms the cancellation. Let's get to the home page again, and now I'm revisiting the history panel for this device. On top we see the saved scenario we just executed, although stopped before the scheduled end. We can download the CVS file encompassing the gathered position fixes with their coordinates and the GNSS time, or a PDF file showing the details of the execution and the trajectory of the device. With only 2 points around the block, it seems like a Hulk aboard the device and went through a couple of worlds. Now it's time to run one more test where instead of on-device processing, we are choosing cloud processing. Having said that, the device does not run any baseband functions at all and just sends the entire captured snapshot for processing to the cloud. We have the luxury in this way to add one more constellation, like Beidou, since the device under testing supports only GPS for on-device processing. I'm going to retain the same label for this scenario for showing later that it won't mix up with the previous one despite they are named the same. Everything else remains unmodified and I'm clicking on the submit button to set the new configuration to both the device and the cloud engine. Let's wait again for the configuration to be enforced. We got a confirmation message and will be transferred momentarily to the tracking page. Let's do some fast forwarding here. After gathering 4 position fixes, it is time again to stop the process and cancel the remaining. Cancellation was applied successfully. The fifth one that just appeared was due to the fact that snapshot had been received before the cancellation and it was under processing in the cloud engine when we pushed the stop button. In the history panel, you could see the scenario we have just executed on top that has exactly the same name with the previous one. In this PDF, the trajectory is visible, although owing to the small area within our colleague ROMs, the outline path does not offer much info. That's all from this video. We hope it assisted you to get a good overview of the LCF user interface. Please, for any additional inquiry, do not hesitate to use the Contact Us form or shoot us an ordinary email at lcf@lacteo.com. Thank you very much.